Hello, geometry students. This is Mr. Tanis. The next assignment we're doing is on composite figures, which is really nothing new. It's the same shapes you did in the last two homework assignments, only now we're adding them together to make these more complex shapes like you're seeing down here with like a rectangle and a trapezoid. So let me just fill these words out here for you so I'm not wasting your time real quick. So a composite figure is a figure that can be separated into regions that are a basic plane figures like triangles, parallelograms, trapezoids, rectangles, circles. To find the area of a composite figure, we just divide up the regions, find the area of each of them, and then find the sum of those areas. So here's an example. There's only 4 examples. We might as well just do all 4, and then you guys can start the homework. So the first example here is one in which we have a rectangle and a trapezoid. So let's do the area of the rectangle first. Rectangle is just base times height. So the formula is base times height, and the base is 23. And the height is 12. So we do that multiplication, and we get 276. And then next we'll do the area of that trapezoid below it, right here. Formula for area of a trapezoid you've learned is 1/2 height times base 1 plus base 2. And the height here we're going to have to find, this whole distance is 18, and then this distance right here is 12. So 18 minus 12 gives you 6. So this distance is 6 centimeters. So we'll do 6 for the height, and then base 1 is 23 because it's a rectangle. These two sides are the same. So we have 23 plus 15. And if we do what's inside of the parentheses first and multiply, we get 114. Alright, so our total area, or the area of the figure itself then, is the sum, which is 390 centimeters. So we'll circle that or box that answer. Okay, the next problem then, or next example, is this one. This one looks a little more complicated, but it looks like it's got 2 half circles, and then I originally split this up into a rectangle, you know, like this rectangle here, and then I had 2 little triangles, but it's actually much easier if you just recognize that these 2 lines are parallel, and so what you have, this big shape in here, is just a parallelogram. So just do 1 circle basically, because 2 half circles make 1 full circle. So we'll do that one first. The area of the circle is equal to pi r squared. Alright, and the radius of those circles is 6. So we have 36 pi. And I'm just going to leave it as an exact answer for now, because I'll end up adding it to the area of the parallelogram, which we'll do next. Alright, sorry, I can spell. Okay. Area of the parallelogram is base times height, as you learned. So the area of the base is 6, and the height is 5, which is 30. Alright, and those are inches. So we're just going to add those together. Now this is what you're going to do in your calculator, and give an answer. It says to the nearest hundredth up above here. So the total area is 36 pi in your calculator plus 30, which gives you 173.1, and I did make a huge mistake here. For the base of the parallelogram, it's this whole distance here. So I needed to use 12 here instead of 6. So 12 times 5, which is 60. So I had half the answer I should have for the area of the parallelogram. But if you add 60 plus 36 pi, you do get the right answer rounded to the nearest hundredth, which is 173.10, rounded to the nearest hundredth. Which you don't need to include this 0 here. I'm just showing that as the hundredths place. Okay, so the next one then looks like we have a triangle, a rectangle, and a semicircle. So let's start with a rectangle, I guess. Area of the rectangle is base times height. The base looks like I'm going to use 9 for that. Now the height I have to find. So over here, we're just going to fill out all the dimensions of anything we can see over here. Okay, so first of all, this is 9, so that makes this 9. The radius of the circle is 9. Alright, and now that we have that, we know this side's 9 as well, because it's again the radius. This distance down, straight down, is also a radii of the circle, so that'd be 9 as well, which then if we do 26 minus 9, we can get this whole side, which is 17. And then 17 minus 7 gives you just this side, which is 10 then. Okay? So be careful not to think that this is the radius of the circle, because we don't know that. But if we can do 26 minus 9, and then that gives us 17 for this whole distance, now we can find this is 10. So now we have all the dimensions that we need to finish this problem. So the height of what we're calling this rectangle is going to be 17. 10 plus 7 here. So 17, which gives us 153, and those are feet. All right, now let's do the area of, I guess, the triangle. The area of the triangle is 1/2 base times height, so 1/2 base times height. The base of the triangle is 9, and the height of the triangle is 10, and that gives us 45, and that would be feet. All right, and then next we are going to find the area of the semicircle. So I'll do area of the circle, which is equal to 1/2 pi r squared. I'm doing 1/2 because it's a semicircle, not a full circle. And the radius of that circle we know is 9. All right, so if we do half of 81 times pi, we get our answer. You guys can evaluate that, which is 127.23. And then if we add up the total area of the whole figure, we get the right answer of 325.23, and that's square feet. Don't forget your units, and there's our answer. All right, one more example. We've got an ice cream cone, which looks like a triangle and a half circle. So we'll do area of the triangle, I guess, first. All right, we're going to need to find that. So what I'm going to do is I recognize I have an isosceles triangle. I'm going to need to find the height of that. So I'm going to use the Pythagorean theorem. This is 8. So if I do 8 squared plus, I'll call this x, I guess. 8 squared plus x squared equals 17 squared. And then I can solve for x, which you guys all know how to do now, which gives you 15. So x is 15. So this distance right here is 15, the height. So it's going to be 1/2 base times height for the triangle. The base is 16. I'm going to use 15 for the height. And that gives us about 120, exactly 120. And then we need the area for the circle, which is 1/2 pi r squared because it's a semicircle. So 1/2, and the radius is 8, so pi r squared. 1/2 pi times 8 squared, which gives us about 100.53. And then if we add those together, this and this, we get 220.53, and that's square meters because both of these units are in meters, and that is our area total for the figure. So let's box that answer. Hopefully these notes help a little bit, but you guys are going to want to practice the homework, check your answers that we've got posted, and ask us any questions if you have them. I hope this helps. Have a good day.